In today's lesson, we're going to go back over relative frequency that we had covered in our last class from school. We're going to talk about words like fair and bias. They are our key words for today. And then we're going to learn what expected frequency means and how to calculate it. Here are some questions for you to do as a warm-up. Pause the screen now, attempt the questions, and check your answers in the next slide. Okay, 2 out of every 100 discs are faulty. Write this as a percentage and as a fraction. So as a fraction, first of all, that is 2 out of 100, which can be written as 2%. What is the probability of a disc not being faulty? Well, if 2 out of 100 are faulty, then that means that 98 out of 100 are not faulty. And we can simplify that fraction to get 49 out of 50. Okay, how many faulty discs are there out of 100,000? Well, if 2 in every 100 are faulty, then you could work it out by going right 2 out of 100 by 100,000. So that cancels there, that cancels there. 2 times 1,000 is 2,000. Likewise here, 2 out of 100 times 250,000, and we're left with 5,000. And finally 1 million. So to write a million, it's 1 and 6 zeros. Multiply that by our fraction and you end up with 2,0,0,0,0, so 20,000. So looking at this spinner here, what is the probability that the pointer will stop on 5? So you can clearly see that each section is split up evenly. So that is 1 out of 5. So you have 5 different outcomes. So they're all equally likely. So you have 1 chance in 5. What is the probability of it stopping on an even number? Well, there's 5 different outcomes it could land on. And the 2 possible even outcomes are 2 and 4. So we have 2 out of the 5 that are even numbers. So our probability is 2 out of 5. So next up, what is the probability of it not stopping on an even number? So what's the probability of stopping on an odd number? 1, 3, and 5. There are 3 ways out of 5. If the pointer was spun 100 times, how many times will it stop on an even number? Well, first of all, just because we can make a prediction doesn't mean that it's definitely going to happen that way. So I would like us to use the word maybe, how many times would you expect it to stop on an even number? Okay, so we know that we are spinning it 100 times and 2 out of 5 is the probability of it landing on an even number. So if we multiply those together, you get 40. So we would expect it to land 40 times on an even number. Okay, I hope that revision has given you a chance to warm up and you're ready to learn some more. Our keywords today are fair and bias. So an event is said to be fair if each outcome is equally likely to happen. So for example, if I were to toss a coin, it's equally likely for it to land on heads or tails. Okay, neither of those things have a better chance than the other. Bias is when there isn't an equally likely chance of everything happening. So for example, if I were to run a raffle in the class, but I put some people's names in twice, then that would be unfair to everyone else and they would have a better chance of winning. So that would be bias. Sometimes it's not possible to predict probability using theory. So when it comes to tossing a coin, we know there are 2 possible outcomes, heads and tails, and we can predict that there is a probability of 1/2 for getting heads and 1/2 for getting tails. Sometimes, however, it's not possible to do that. So for example, if we wanted to find out what is the probability of landing the bottle when we do a bottle flip, we don't have any theory behind that. So we would have to carry out a number of trials and record how many times we landed it and how many times it didn't land. So this gives us an estimation, and that estimation is called relative frequency. So the number of successes over the total number of trials. The more trials you do, the more accurate your estimate will be. So we need to carry out experiments. Sometimes you would plan that experiment yourself. And it's really useful for situations where things aren't equally likely. So here's an example of an experiment that has already taken place. So there's an 8-sided spinner with numbers 1 to 8. The arrow has been turned a number of times and the results have been recorded. So we can see here that the number 1, that section was landed on 72 times. The number 2, that was landed on 71 times, and so on. We're going to work out the probability, or an estimate for the probability of landing on a 1, a 2, a 3, a 4, a 5, or so on. So in order to work out the relative frequency, we need the number of successes. So in that case, if you were to think about the relative frequency of landing on 1, that's 72, over the total number of trials. So in order to work out the total number of trials, you need to add up the frequency here to get the total frequency. Okay, so add those together and you will get 772. Okay, so I'm going to record that here. Total frequency. Okay, now it's simply a case of working out the relative frequency for each one. So for the first one, it's 72 over 772. We're not going to leave our answer like that. We're going to write it as a decimal. And if you want, it's also sometimes useful to write it as a percentage. So as a decimal, and you can use your calculator for this, it's 0.09326 and so on. And as a percentage, that is 9.326%. Okay, so if you're not sure how to go from fraction to decimal to percentage, look back in your copy from when we did this before the midterm break. So for the next one, it's 71 over 772. That was quite similar, so I reckon the relative frequency will be quite similar as well. So that's 71 divided by 772, and that gives us 0.09196 and so on. So I'm going to round that to 0.3, sorry, excuse me, making a mistake here. 9.19, and if you look at the numbers on your calculator, we're going to round that to 197. So the next one is 66 over 772. And that works out to be 0.0855 when you round it. So that's 8.55%. Okay, let's keep going. 7 out of 772. So you can see these are all quite similar. So 70 divided by 772 is 0.0907. So let's go for maybe 4 decimal places. So that's 9.07%. Be mindful, I am rounding as I go along. Don't worry if you're not sure how to round for now. I'll go through a video on rounding later. So 73 out of 772. That's actually repeated here, so I'm just going to do it all at the same time. So 73 divided by 772 is equal to 0.0946. So 9.46%. Okay. The next one, you can see this is quite a big jump. So it seems that 6 has come up quite a lot in comparison to everything else. So does this seem fair to you? If it's not fair, then what word would we have for that? Okay, so 278 divided by 772 leaves us with 0.3601. So that's 36.01%. So you can see the probability of getting a 6 is a lot bigger. So for the others, we're around 9%. And for this one, we're at 36%. So about 4 times as likely to land on 6 than the other numbers. And then finally, 69 over 772. Leaves us with 0.0894, so that is 8.94%. So we've worked out the relative frequency for each outcome. Is the spinner fair? The answer to that is no. You are more likely to get a 6. So not equally likely outcomes. So that would be a good sentence. Not equally likely outcomes. So maybe take this down in your copy. Take the table down. Take the questions and the answers down. And there's another question for you to do on the next slide. So take this down into your copies. Make sure that you work out the total frequency. Write your relative frequency as a fraction, then a decimal, and then a percentage. Answer the questions into your copy. Take a picture and send it to me. Okay. The next thing we're going to talk about is expected frequency, and we've actually done this already in this video. We did it at the start of the lesson. So a lot of time the reason why we do probability is that we want to be able to predict, we want to know what to expect. So if you tossed a coin 10 times, how many times would you expect it to land on heads? You'd tell me straight away you'd expect it to land 5 times, and the reason for that is you know that half of the time it will land on heads. So that gives us 5. So basically it is our probability, which was a half, multiplied by the number of trials, which was 10. Okay, so what I'd like you to do now is take that key point down into your copy. Pause the video if you need to. So I'm going to go through this question as an example, and then there are 2 more on the next slide for you to do. There are 60 jelly beans in a bag, all either green or yellow. Rye takes a bean from the bag without looking. There is a 50% chance that the bean is green. How many green beans are there in the bag? So how many, if you were to take them all out, how many would you expect to be in the bag? So it's going to be our expected number of green beans equals the probability, sorry for my handwriting, multiplied by the number of beans. So 50% of the beans are green, multiply that by the number of beans, and you end up with 30. So in your copies now, I would like you to have a go at both of these questions. You don't need to take the question down, but you do need to write things down, like the expected number of red, the expected number of green, things like that. Write down probability times number of trials. So make sure you're showing off every step of the calculation. I know that these aren't tricky numbers, but what we're practicing here is how you show off your work.